Buddy, I just wanted to come through with this one because it's pretty interesting. It's called just interesting on scientific discovery level. Uh, so let's look at it. Interstellar tunnel that connects our solar system to other stars. So it says space can surprise even those who spend their lives studying it. People often think our solar system is just it's just a few planets and a bunch of empty space. There's a lot of damn ads on here. Yet new observations suggest that we have been living inside a hot, less dense region, and that they may even be strange cosmic channel connecting us to distant stars. After years of careful mapping, a new analysis reveals what appears to be a channel of hot, low-density plasma stretching out from our solar system towards distant constellations. Astronomers from the Max Planck Institute recently confirmed it using data from the eRosetta instrument. Dr. L. Sala, lead researcher, and colleagues shared these findings in a paper published in the Journal of Astronomy and Astrophysics. Looking beyond the familiar. For a long time, scientists have known that our solar system sits within a peculiar region of space called the local hot bubble. This area, estimated to be about 300 light years across, formed as a result of powerful stellar explosions called supernovas. They heated the surrounding gas, producing a low-density, high-temperature environment. Traces of these distant events still linger as wispy distributions of hot plasma. We find the temperature of the LHB exhibits a north-south dichotomy at high altitudes, stated Dr. L. Sala, lead author of the study. A cosmic X-ray explorer. To better understand this environment, scientists turned to eRosetta. This X-ray observatory launched as a part of the Spectrum Roentgen Gamma mission, scoured the sky to capture soft X-ray emissions. One of eRosetta's goals is to chart hot gas in space, learn about supernova remnants, and investigate the surroundings of our neighborhood. By combining these results with older data, ROSAT, another X-ray survey, astronomers have pieced together a more detailed picture of our local region. They took on the challenging task of dividing the sky into thousands of bins, extracting subtle signals of warm gas, dust cavities, and interstellar structures. This painstaking approach helped isolate the faint glow of the surrounding plasma. What stands out is the detection of a channel or tunnel that appears to stretch towards Centaurus constellation. This feature seems to punch through the hot material connecting our neighborhood to distant stars. Another such pathway appears to link towards the vicinity of Canis Major. Data hints these might be just one part of a larger branching network of channels that run between stars, forming regions and pockets of heated gas. And this is a 3D map of the Milky Way's local hot bubble created from East Rosetta's data reveals a low-density region around the solar system heated by ancient supernovas. The bubble shows temperature gradients and interstellar tunnel towards Centaurus, likely formed by young stars' winds This bubble may connect to other superbubbles, shaping the Milky Way's structure. The solar system entered the LHB a few million years ago, adding to our understanding of its cosmic neighborhood. They credit Max Planck with this institute. So it says each route may represent a kind of interstellar backroad, a path carved out by dynamic processes and influenced by the long ago actions of exploding stars. Remembering old theories on cosmic channels, ideas about a network of hot, low-density channels are not new. Decades ago, some researchers speculated that the space around us could hold labyrinths of connected cavities, but there was never enough data to be sure. Instruments like eRosetta have now provided that clarity. By showing tunnels and pockets filled with hot plasma, the findings confirm at least one piece of these older theories. The presence of dust cavities packed with hot gas supports the notion that supernova events shaped a connected patchwork of interstellar matter. So it's not just empty space. It is tempting to think that of space as nothingness, but that is misleading. Even the void between stars contains various materials. The local hot bubble is one example of how dramatic events can sculpt gas into unexpected forms. Supernovas push out matter and energy that heat and churn the interstellar medium. So there's an interstellar medium. Over millions of years, these actions create differences in density, temperature, and composition. The interplay of dust, plasma, radiation, and magnetic fields leads to an environment with far more complexity than a simple vacuum. The Max Planck Institute recent study argues that the average thermal pressure in this bubble is lower than expected, indicating that it might be open in some directions. While researchers have mapped parts of this hot region and uncovered these unusual passages, not every aspect is understood. Some star lines seem supported by a series of linked cavities. Other regions appear more blocked. The complexity of these patterns requires more sensitive data and further analysis. With time, better models may explain how these structures formed and how they continue to evolve. Space's calm appearance is deceiving. Over the past millions of years, our solar system drifted into the local hot bubble. At roughly the same time, supernovas occurred nearby. The timing is not a coincidence. Those ancient blasts likely shaped the conditions we find today. The fact that our sun now sits near the bubble's center is simply chance, but it makes for an interesting perspective. It is as if we arrived late to a party only to find a lingering aftermath of dramatic events that took place before humans even existed. Peering inside a hidden structure. Continuing to explore these cosmic channels will require increasingly sensitive instruments. New X-ray missions, deeper surveys, and refined models of hot gas distribution will improve our understanding. Over time, astronomers hope to fill in more of this cosmic map and explain how these tunnels affect everything from local cosmic rays to dust flow patterns and stellar wind dynamics. The discovery of these hidden routes and temperature differences offers a reminder that even our own cosmic backyards holds surprises. These channels challenge old assumptions and add complexity to the picture of what lies between our sun and the near stars. As technology advances and new methods improve, these discoveries are bound to raise even more questions. Every new piece of evidence will bring us closer to understanding both the space we inhabit today and the ancient events that shaped it. What once seemed distant and unknowable may soon reveal connections that redefine our place in the cosmos. All right, so that was a pretty interesting article to me. You know, when you discover something in space, like what you call a tunnel or a portal, less density, higher density, it's just like, we're traveling through air, when we're, walking on the surface of the earth. But, we know that there's water. There's really dense water underneath, layers and layers of ocean. And sometimes it's so dense that, different sorts of life have to evolve differently to exist in those pressure conditions. And of course, up in the atmosphere, the upper atmosphere is much less pressure, it gets colder. So the pressure actually determines a certain condition. So when you're going through space, there's some places which less dense and some places are more dense. So that's going to affect how you move through those areas. You can't, like if you're flying a plane can't fly through air the same way it can go through water. You have to have different structure. Submarine, through water, an airplane through air. You see? So, I just thought that was interesting. And, that may affect, it's just interesting how these things formed ancient. So that also is a way to if you can determine how long it would take a supernova, how many of these tunnels exist, how long it would form, it would take to form that tunnel, then for that supernova plasma and everything to kind of dissipate to where it just looks like empty space now. That you can put a time frame on that, because really and truly, I don't believe they have a good way of knowing how old the universe is. They're looking at the Hubble tension and all of this stuff with the they call the Hubble tension and all of this mess with the fact that they're looking at the shrinking of what they see as the known observable universe, and then they kind of backtrack that to a single event called the Big Bang, and then they estimate that at about 14 billion years ago. But that doesn't mean that the whole universe is 14 billion years old, as if that's the beginning of existence. But that's all they had, so that's all they say. But just like Terrence Howard said, if the Earth, which it is moving away from the sun at a rate of about 2 inches a year, because the sun loses density every time. It just loses density because it's sending out so much mass in the solar radiation, the solar winds, the solar dust, that it's actually slightly less dense. And so everything that's rotating around our sun, it kind of moves back, it moves away from the sun just ever so slightly. Every year, it's an average of about, an inch, a couple inch and a half away. So, if the Earth is 93 million miles away from the sun, it's just giving you an estimate of what time it is. Multiply an inch and a half times an inch and a half. How long will it take to reach even 90 million miles? How long was that? How long does it take you to cover a distance of 90 million miles? and at a rate of 1 inch, an inch and a half per year. How many years is that? So because all this matter comes from the same source, which is what we look at as the sun. But all these planets, it was all together at one point. And
the Earth has been moving away from the sun since the moment that it formed. That means every 10,560 years, the Earth moves 1 mile away from the sun. In order for the Earth to be 93 million miles away from the sun, that means the Earth would have moved 982 billion 80 million years. It would take 982 billion 80 million years in order for the Earth to reach 93 million miles away from the sun. Well, that means that's linearly.
in the distant, past. So, it's just something to think about. Something to think about, to learn the universe, to learn how the stars work. You have to keep an open mind. One of the things about the scientific community that I don't like is when they just so-called discover something and they speak of theory as if it's fact. Just because they don't have any other explanation that they know, they speak of it as if it is a fact. And just because you can't explain a different way, but because a different way is possible, that's the reason why you don't speak on theories as a fact. Because it's not conclusive. It's not a law. We still have a lot of stuff to discover. So, that's my thoughts on it. Tell me what you're thinking about. I know a lot of people think that there's just a pool up there. There's just with a firmament. They think that, the earth is not round. There's a flat earth. There's a lot of theories, and then you can't tell people anything on their stuff. It's amazing to me. It's amazing to me how, people just go with, some sort of doctrine, and even if it doesn't square with the reality that they're walking in. But let me know what you think, guys. Peace.